In this video, we'll see how to convert a hexadecimal to octal number system. So when we are converting a hexadecimal number system to a octal number system, so the thing is that there is no direct way for that. We have to use a intermediate stage there. Okay, so there will be an intermediate stage. That means the hexadecimal number system has to be converted to a decimal number system, or it has to be converted to a binary number system, and from there it again converted back to the octal number system. So there is no direct formula for that. Now to convert that, we need to remember two things. So whenever we are representing any hexadecimal number system, then we have to represent with a group of 4 bits, and that is why, because in hexadecimal number system the highest number is 15, and that is represented as 4 ones. That means 4 bit is mandatory for hexadecimal number system. When we are representing a octal number system, we have to represent it at 3 bit number system. Why? Because the highest number in octal number system is 7, which is 111. Okay, so that is why the hexadecimal number system has to be presented in a highest number system with 4 bits of binary digit, and your octal number system has to be presented in a 3 bit of binary digits. Now let us just take a small example and then we'll explain how to do this, how to do the conversion here. So let's just take, I'll take A and base 16. What is the equivalent in base 8? So this is the question. So how to do that? So we have to represent the hexadecimal number system in its 4-bit binary number system. So A means what? A means we know it is 10, right? A 10 is represented as A in hexadecimal number system, and the binary equivalent for 10 is 1010. Okay, so how it is? So this place is 8 plus 0 plus 2 plus 0, so that is 10. So 1010 in binary number system, it is there for the hexadecimal number system equivalent of A. Now how to convert that to 8? So as I said, 8 has to be represented in 3-bit equivalent binary digit. So this 1010, I am writing here again, 1010, we have to make a group of 3 bits in this number. So if I make a group of 3 bits, from where to make it? From right to left. Okay, just move in this direction. So take a group of 3 bits, and here also only 1 bit is remaining. So to make a group of 3, I will add 2 zeros here. After that, what you have to write? I have to write what is the equivalent of this. So equivalent of 010 is what? This is number 2, and equivalent of 001 is 1. So here the answer will be 1 to base 8. Okay, so let us take another small example. So if I write 2f in base 16, what is the equivalent in octal number system? So how to do it? So represent the 2 individually as a 4-bit number system. So that will be 0010. Then represent f as a equivalent binary system, that is 1111. Okay, next what I have to do? I have to make a group of 3 to convert that to octal number system. So from right to left, I have to make a group of 3. So this is 1, then this will be 1, and here another one will be there, it will be 0. Okay, so what is this 111 now? I know this 111 is 7. What is this 101? I know this 101 is 5 here. Okay, so here the final answer will be 57 with base 8. So this is the octal equivalent of this number. Now let us take another example. So if I write 1BF, okay, in base 16, what is the equivalent in base 8? So how to do? So first I have to write the binary equivalent of all the bits individually. So for 1, it is 0001. I have to represent in 4 bits. So B means what? B means 11. So 11 means 1011. So this will be your 11. And what is F? F is 1111. So 4 ones. Now I have to do group of 3. So from right to left, I will make one group. So this will be another group. This will be another group, and here it will be 0. Here no need to add any zeros because already 3 zeros are there. Now this equivalent is 7, this equivalent is 7, 110 is 6, and this is 0. So here the answer will be 6, 7, 7. Okay. Sorry. So next is, if there is a decimal point, then how to do it? So let us just take a decimal point. If I write 1.2 in hexadecimal number system, what is the equivalent in octal number system? So if decimal point is there, then also the process is same, only the grouping mechanism changes here. So just write the binary equivalent of the numbers in the hexadecimal number system. So for 1 it is 0, 0, 0, 1, then point is there, then 2 is 0, 0, 1, 0. Then what I have to do? I have to make a group of 3. So before the decimal point, use the normal process. So this is one group, this is another group. I have to add 2 zeros here, right? After the decimal point, you make the same group of 3, but in left to right, in the opposite direction. Okay. So you have to add 2 zeros here if no zero is there, means number of bit is not 3. Now this equivalent is 1, and this equivalent is 0, and this equivalent 0, 0, 1 means 1, and this is 0. So here the answer will be 01.10. This is the octal equivalent of the binary hexadecimal number. Let us take another example here. If I take 32.A1 with base 16, what is the equivalent in octal number system? How to do that? So here I have to represent 3 as a 4-bit equivalent. So it will be 0, 0, 1, 1, that is 3. Then 2 will be your 0, 0, 1, 0. Then point A is 10. So that is 1, 0, 1, 0, and 1 is 0, 0, 1. Sorry. 00001. Then I have to make a group of 3. Before decimal point, it will be group of 3 like this from right to left. Okay, well, no bit is there, so I have to add 1 0. So this equivalent is 0, this equivalent is 6, 0, 1, 0 is 2. And after the decimal point, you have to make a group of 3, but after this left to right. So first 101, this equivalent is 5, then 000, this is 0, then 010. So 010 is 2. So the answer here will be 062.502. Okay, so this will be the octal equivalent of the hexadecimal number system with decimal points. Okay, now I think it is clear. In your octal to hexadecimal, represent as 3, then make a group of 4. In hexadecimal to octal, represented as 4 bits and made a group of 3, and then converted to octal number system.